Okay. Data analysis. All right. Some easy things to begin with. Things that you should already know. Mean. Another word for now. But yes, mean is average. It's also represented as X bar in your calculator, so when we're going to use it, we're going to see it as X bar. It pretty much is the sum of all the, in table format, it's the sum of all your frequencies times by your scores over the sum of frequencies. Or in other words, you know that, right? Or in other words, it should be the sum of your scores, over number of scores. Okay, so there's the sum of scores. That's what that means. That means sum of. And that also means sum of. So sum of all the frequencies, which is the number of scores altogether. Cool. Okay. We have the interquartile range. Usually worth 1 mark in the HSC. Nice and easy. The third quarter, take away the first quarter. Okay. Interquartile range, third quarter, take away first quarter. We've already had a look at that last in the prelim. Now we're going to look at it a little bit more in detail. And standard deviation. Standard deviation, you don't need to know the formula because it's really hefty. For now, all you got to do is learn it the calculator way, which I think we've already done it, okay? But the formula is X, something like that, okay? So like I said, you probably don't want to do that by hand. I told you. That's my job, not yours. Okay. So I'm going to move on from mean and stuff. I'm going to assume you should know how to do that. Median is the middle number, so I'll put that here as well. So then you can just print this off for your little formula sheet pretty much. Middle number, and then we'll do mode. Most occurring. When you're doing your median, if you have your table format, then you have to use your cumulative frequency. Okay, and we're going to look at that soon as well. So how to use cumulative frequency to actually get my median, for example. Okay, so all should be good. All right, so imagine now I had, no, that should be okay. All right, we had a stem and leaf plot. Do you know how stem and leaf plots work?
I think so, yeah.
Stem, leaf. 2, 3, 4, 5, 6, 0, 1, 2, 3, 3, 6, 4, 2, 1, 5, 5, 7, 8. It must be ordered from lowest to smallest. What's the smallest number in this scores?
20.
20, and the highest number is?
68.
So what's my range?
68 minus 20.
Yeah, so that's highest, take away lowest. Okay. Median, obviously the way you would go about doing it is cancelling the first one with the last one. So 28, 7, 1, 65, 22, 65, 33, not 36. Okay, 51, 33, 42, 36, and the last one must be. All right, mode. Which one occurs the most? Well, there's 2 3s, then there's also 2 5s, so your mode must be 33 and 65. And your average. Your average is you use your, just go add them up. Okay, so 20 plus 21 plus 22. There's no other way really. So that's it. Okay. I reckon new page, because it's a hot topic now. All right, now we're going to look at part 2. Measures of spread. So we have median. Look, a lot of people look at average, right? When you're thinking of stuff, you're looking at always an average. And I've told you that's the uneducated person that would look at average, because they'll think, okay, average is always the middle, or trying to find, you know, what a lot of the scores are. No, average is not the best predictor. It's actually median that's the best predictor. Okay, so for your future life, if you want to remember that, median is your best thing. So as I say there, I wrote term 1 average, for example, 86.25. The median is actually a lot smaller. Okay, and the reason why that is because average is always going to give me a higher number than my median, and that's because obviously some scores are going to skew my average to be a lot higher. With my median, it won't do that. Okay, because I'm trying to find what the most occurring number kind of is, kind of, and the reason why that's mode as well. But average, like I said, it has skewness. So unfortunately, if someone gets a couple of people get 100, that's already going to skew my average up really high. Whereas with median, it doesn't make a difference if some people are going to get 100 because that's going to get offset with the first couple that are low. So you should always look for median. Anyways, we're going to look at spread, like I said, more than anything right now. So we have range. We have interquartile range. So we understand range. So we're going to interquartile range. I already said that's Q3, take away Q1. How do you find Q3? So you probably have some sort of distribution of scores like that. You have that being Q. What do you reckon?
Q1.
No.
Oh, Q2, sorry.
That would be Q2.
Q1 is to the left.
Q2 means what?
The median.
It's actually the median. That's Q1. And that's Q3. Have we looked at box and whisker plots already? In prelim?
Oh, we did it in class.
Yeah?
Yeah.
Okay, perfect. So that's Q2, which is the median. Q1 is your first quartile, and Q3 is your next quartile. Now, that's your highest score, that's your lowest score. Q1 is the 25th percentile, that's your 50th percentile, or 5th percentile, as what we learned before, and that's your 75% range. Alright, anything else? Alright, let's actually show you a question now. So imagine I had these numbers. 6, 6, 7, 9, 10, 12, 12, 14, 14, 16, and 18. We want to find the median, the range, the lower quartile, the upper quartile, and the interquartile range. Okay, so let's work out the median first. There's roughly 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. So I'm thinking 4, 5, the sixth number there, that should be my median. So Q2 is equal to 12. Let me use a different color so I get it mixed up. All right, Q2 equals to 12. Now I'm trying to work out my my Q1. How do I do that?
You split it in half.
Yes.
The median.
Yes.
And then you find the median of the first half.
That's it. You got it. So that's my Q1, and that's my Q3 pretty much. So you find the median of those. That's it. So Q1 is equal to 7, and then Q3 is equal to 14. Therefore, my interquartile range is 7. 14 take away 7. Okay. Oh, they did 12. I must have missed one. Doesn't matter. 14 take away 7. Okay. We understand standard deviation. Forget about that. We should know all of that. Okay. Outliers. Massive. Do you know what an outlier is? Okay. Nice and easy. The word should say it all to you. An outlier, imagine you have data points. Imagine if I scattered them up and it looks like something like that, right? An outlier would be something like that's away from all the distribution. There. That's classified as an outlier because it looks to us like there's been an error. Probably an error in, let's say, maybe when I'm entering my data, I've entered it incorrectly. I might have put 105, or it was just meant to be by a 0.5, for example. Or 10.5 actually, it could have just been 10.5, I put 105. It could mean, most likely that's an error, okay? So it's actually, it is an error, but how? It could be through a lot of things. I mean, when you're surveying someone could be just wanted to write some like a false lie, for example, and they did something like that. So that's what scatter plots show you, and an outlier, something like that. So it's out there, it's on its own. alone, however you think about it. Okay, so they do distort our data a lot. And then I think the way they did it, they wrote, like they did it from a dot plot. So you see there's like a cluster kind of thing here. Okay, and then a large gap, and imagine there was like 2 dots there. Well, obviously that's an outlier because then there's something wrong with that. Nice and easy. Okay, here we go. Then we have skewness. Okay, you understand what a cluster is? Again, hopefully you're just seeing it via its words itself. So a cluster. Yeah, a gap, outlier. I thought so. Positively skewed and negatively skewed. All right. Remember how I've always said if it's sloped to the right, it's positive?
Yeah.
Now it's exact opposite for skewness. Okay? So you have what we call a bell curve. Again, we'll learn this more, I think, when there's another topic, like an extension to this, we'll learn later on. Oh, no, we'll do it. We'll do it now. Okay? Normal distribution. So this is called the bell curve. Okay? And it's a normal distribution. So we're trying to say things are normally distributed by this curve, for example. You'll understand that a little bit more later on. Or if you were to carry on statistics like me, but you weren't. So we're going to look at skewness. That is obviously saying that there's no skewness. Okay? Positively skewed would look like this. Negatively skewed would look like this. Okay?
Yeah.
So it's skewed to the right. It's actually negative. So let me write skewness now. Okay, so it's exactly opposite as before. And yes, these have been marks on the HSC. All right, they just ask, okay, describe the actual distribution, describe the skewness, for example, or describe the actual data. Yeah, if it's skewed to the left, skewed to the right, you would also get full marks. Okay.
But you should write that.
Yep, skewed to the right, it's full marks. Cool. Any questions?
No.
Back-to-back stem and leaf plot. I'm not going to go over that. I think it's pretty much self-explanatory again.
Yeah.
All it is you've got your stem here, and then you're going to have 2 leaves.
Is it like 2 sets of data?
That's it. This could be for, data A and data B people. And then the way you find the median of A, you'll do the same. The way you do the median of B would be the same. But if you wanted to find the median of the whole thing, that's the one that's a little bit more interesting.
Okay.
So maybe we should do that.
Is that commonly asked?
Yes. That was asked, I think, just last year. As you can see, it decreases.
Mm-hmm.
Okay, so what you want to do is if it's for the whole data set, remember, what did I say before? You want to do the highest number, take away the lowest number then. So it should be 46, take away 20.
Mm-hmm.
So you're going to go 46, take away 20. You're going to do 45, take away not 25, 23.
Okay. Yeah, and then 24.
That's it.
Yeah.
That's you get it. I mean, once I tell you that trick, that's it. So then it's 40, not the 30s yet.
Mm-hmm.
And then it's 34, and it doesn't make a difference now which 25 you pick. Okay, so you can pick this 25, or you could pick the other 25.
Mm-hmm.
All right. So what did I say?
Will the next 25 be next?
34. Yeah, doesn't make a difference as long as because you know the next one's going to be next exactly. And if you had a problem like which 25 should I pick, for example, if it's A or B, it's still going to be 25 at the end of the day, right?
Yeah.
So you don't really care if it came from A or B in that case. So anyways, 30, so 4's gone. Where am I? 33, and then the next 25, 32, and 26 will be the next smallest one, and so forth. 31, 27, and then obviously your answer is now 28 because you get two 28s left, so your answer must be 28.
Mm-hmm.
That's it. Cool. Okay. All right. Histogram. So we remember what a histogram is?
Like frequency histogram.
That's the one, right?
Yeah.
So I'm going to try to show you for a box and whisker plot what the histogram is actually trying to say. So the histogram for this would look something like this. Probably going up, yeah, a little bit. Okay. It will actually be equally distributed. Can you see there's the normal distribution I was talking about before?
Mm-hmm.
So that's because it's very symmetrical on the left-hand side and the right-hand side. Cool?
Mm-hmm.
Okay. Now, if I have something that's a little bit to the left, positively skewed, for example, as we said, I should have written, I wrote skewed to the left, right? Hopefully I wrote skewed to the left, not to the right. So if it's positively skewed, it's going to look like this. And then you could have a little bit of a higher one here. All right, I should redraw these. Give me a second. Something like that. And then you're going to have probably a small one. But then at the median, you're going to have slightly bigger. And then it's going to be smaller, smaller, smaller kind of thing. All right, something like that.
Why does it get that little bit bigger? At the median?
Because your median is always going to be higher than this point here.
Okay.
And then you're really looking at your distribution more than anything, your skewness of it. And the fact that these numbers here, okay, I mean, you got your highest number,
Yeah.
but you're saying your median, look how far it is away from your highest number.
Okay.
Can you see that? So you're really saying that, like, if, like for example, if let's just say if for my average could have been here, right? The highest number could have been here. But then all the scores, the median could have been down here. But because of one person, it could have skewed it up.
Mm-hmm.
So that's what this kind of shows. It shows that, okay, everything's towards the left that's pushing it up. And then the only reason why this one must be a little bit higher was because of that median. The fact that your median usually should be a bit higher than everything else. Sometimes, not always. So it doesn't make a difference. I think they're just trying to show you that at the median, it's going to be elevated up a little bit.
Okay.
Okay, it's just the way normally it's going to work.
Because I just don't
Understand the mechanics of it. I don't know.
how like the histogram represents the box and whisker plot, like the numbers and stuff.
Oh
Like how would it be?
okay. Well, look. Look, your median is very close towards these numbers,
Mm-hmm.
right? And these numbers are all low.
Yeah.
Aren't these numbers low? If it's on the left-hand side, isn't it more lower?
Yeah.
So aren't these
But
numbers
are you saying
lower?
that they occur frequently by like the high.
Well, this is box and whisker plot is a frequency. It is a frequency kind of plot, isn't it? Aren't you going, okay, this is the way the 25 percentile is, that's where the 50 percentile is. So that's 50% of the scores are on this half already.
Yeah.
And then 75% of scores are here already. So it must be all pushed to the left-hand side. So if I draw you the other one, if I draw you the opposite one of it, which would be this way, well, you would assume the histogram for that should be something like this then. Whoops. You would assume it's being something like this. I can't scroll any more down, but you would assume it being something like this. For example. And then this could be a little bit higher, and then probably lower, lower, lower. And then it would look like that. Again, and the reason why, because your 75 numbers are all down up here. So all your scores are all towards the other end, the higher end. Sorry, I shouldn't have drawn that there. I should have drawn that here, of course, right? There you go. Cool. It's all towards the higher end. And it's true. Like I said, think about your numbers. Think about these scores that these represent, right? If you want to do it from 1 to 100, right? Think of the score that is. Think of the score. Go tell me.
What do you mean? Like any number?
Any number between 1 and 100. What could that one be?
Like 80?
Yeah, like 80, right? So in this, that's 1 to 100. Right? There's your x values. That's your 1 to 100. 80 should be somewhere here. Is 80 a high frequency or low frequency here? In regards to this, it's a 75th, like it carries 75% of your data. So it carries a lot of it. So there's going to be a lot of frequency there.
Mm-hmm.
And then vice versa for your lower numbers. So if a number was here, it has very little frequency. This doesn't tell you the actual frequency. Like I say, it's like a frequency plot. It doesn't tell you. It's just like it kind of gives you the rough plots. It's more for the percentiles. Okay, it tells you like 25% of them is here. So if 25% of the data is here, that means the rest is so minimal that we're not even caring about it. That's the whole point of the streamlining.
Okay.
Cool?
Yeah. But just the like so the top one.
Yeah.
See that rise? Like what part of the box and whisker plot does that represent? Like I don't understand how you convert a box and whisker plot.
Oh, you won't. You're not going to. Oh, you're not going to draw this.
You scared me. What the heck's going on?
No, you're not going to draw this. Look, that could be a lot of things. I'm just showing you from my understanding. Like, that could be an outlier for all we know as well. It could just be, maybe it was going to be like this. It was meant to be going down all the way. But then something's happened there. And you'll be like, okay, let me go have a look at that. Let me go understand that a little bit more.
So will we ever have to turn a box and whisker plot?
If you were, then it would just say to draw a rough distribution of it, which is this. That's all I'm interested in, the skewness. Not the actual histogram.
But
the histogram you can only draw from actual data points. So I have to be giving you a table.
Yeah. But see how it's more like...
It's more to the left. That's the main point. Yes. That is something you need. So yes, you do need this part here.
But why is it's more to the left in this instance?
Because there's more numbers. Look at the 75% of them. Again, pick 1 to 100 here. Right? What could this number be, for instance?
60.
Right. Halfway's here. Let's say halfway's there.
40.
40. Right? So it's saying 75% of the numbers compared to 100 is up to 40 already.
Oh, okay, I get you.
So then a lot of it's going to be in the smaller region rather than the bigger region.
Okay.
That's it. A lot of the numbers are going to be in the bigger region compared to the smaller regions.
That's so simple.
That is simple.
I was like, where is it?
Yeah, I know. That's okay. Alright, so look at that one next. Comparing box and whisker plots. Oh yeah, that's actually been, I think, in almost every single exam I've seen. So let's do that. But those are easy ones. I'll probably get a HSC question up now. Let's actually go on to this and get a HSC question. Can I pause this by any chance?